We are all going to die because of problems in coral reefs. Hello everybody, today I'm going to be talking about the problem that coral reefs face. Overfishing in coral reef ecosystems is a significant problem, leading to the depletion of fish populations and the disruption of marine food webs. Evidence of this problem includes declines in fish abundance and diversity, changes in fish size distribution, and shifts in species compositions within coral reef communities. Scientific studies using underwater surveys, fisheries data, and ecological modeling provide evidence of overfishing's impact on coral reef ecosystems. Factors contributing to overfishing include unsustainable fishing practices such as blast fishing, cyanide fishing, or the use of destructive fishing gear, inadequate fisheries management, lack of enforcement or fishing regulations, and increasing global demand for seafood. The biogeochemical cycles within coral reef ecosystems are complex and interconnected, with both biological and physical processes driving the cycling of key nutrients essential for the growth and maintenance of reef organisms. Problems such as overfishing can disrupt these cycles, leading to the ecosystem degradation and loss of biodiversity within coral reefs. Now, biotic factors and abiotic factors. Biotic factors include fish population dynamics, which is the abundance, diversity, and reproductive rates of fish species in coral reefs that play a crucial role in regulating fish stocks. Overfishing can disrupt natural population dynamics by removing key species, leading to the imbalances in the ecosystem. Predator-prey interaction is the predatory fish species that help control the population of herbivorous fish and invertebrates, which in turn regulate algae growth and maintain reef health. Overfishing of predators can result in increased herbivore abundance, leading to the overgrazing of algae and potential coral reef degradation. Competitive interaction is the competition amongst fish species for resources, such as food and shelter, that can influence the distribution and abundance of species within coral reef ecosystems. Overfishing can alter competitive dynamics by removing certain species, potentially favoring others and disrupting ecosystem balance. Ecosystem engineers is some fish species, such as ferrets or surgeonfish, that play important roles as ecosystem engineers by shaping reef structures through grazing and bioerosion. Overfishing of these species can impact reef resilience by altering reef morphology and reducing habitat complexity. Abiotic factors such as ocean warming, acidification, and extreme weather events associated with climate change can exacerbate the impacts of overfishing on coral reef ecosystems. These stressors can weaken reef resilience and make it more challenging for fish populations to recover from overfishing pressure. Abiotic factors such as pollution, sedimentation, and coastal development can degrade coral reef habitats, reducing their capacity to support fish populations. Overfishing in conjunction with habitat degradation can have compounding effects on reef ecosystems, further compromising their health and resilience. Coral bleaching events driven by factors such as elevated sea temperatures and thermal stress can disrupt the trophic dynamics of coral reef ecosystems. Bleaching events reduce coral reef cover and habitat complexity, affecting the abundance and distribution of reef-associated fish species and increasing their vulnerability to overfishing. Now, what about the future effects it has and how it will affect the world? The future effects of overfishing on coral reefs could be severe and wide-ranging. Continued overfishing could lead to the collapse of fish populations, loss of biodiversity, degradation of coral reef habitats, and the disruption of ecosystems functioning. This could have cascading effects on other marine species, livelihoods of coastal communities dependent on fisheries, and marine ecosystem services such as food security and coastal protection. It could later affect the world, as the entire world is based off a food chain. If one removes coral reefs, millions of sea animals would lose their home and food, causing their extinction, which will slowly affect all animals, including us humans. Now, how is the problem being solved? There are multiple forms of treatment that are being applied to help solve overfishing. Scientific research is used to inform fisheries management strategies aimed at ensuring sustainable fish stocks. This includes conducting stock assessments to estimate fish populations, monitoring catch levels, and identifying overfished species. Science plays a crucial role in the design and management of marine protected areas, which serve as sanctuaries for fish populations to recover from overfishing. Science and technology are advancing innovative solutions to address overfishing, such as improved monitoring and enforcement techniques. For example, the use of satellite technology, drones, and underwater cameras allows for more accurate monitoring of fishing activities and enforcement of fishing regulations in remote and inaccessible areas. Laws and regulations related to overfishing vary by region and country, but often include measures such as fishing licenses, gear registration, and marine protected area designations. International agreements and conventions such as the United Nations Convention of the Law of the Sea, UNCLOS, and regional fisheries management organizations play a role in regulating fishing activities in shared water. What can one do to help? You can choose sustainable sourced seafood products certified by reputable organizations such as the Marine Stewardship Council or Seafood Watch. You can avoid consuming endangered or overfished species and opt for alternative seafood options. Get involved in local conservation efforts aimed at protecting coral reef and marine ecosystem. This could include volunteering for beach cleanups, participating in citizen science projects, or supporting organizations working on marine conservation. Raise awareness about the importance of sustainable fisheries management and the impact of overfishing on coral reefs and marine biodiversity. Encourage others to make informed choices about seafood consumption and advocate for policies that promote sustainable fishing practices. What are the benefits and limitations of applying science to the problem? By using science, one can get better and clear results on the investigation. It can allow research teams with essential information and insight into the different fish species and the health of the ecosystem. Science-based approaches such as stock assessment, fishing quotas, and marine protected areas aim to ensure the long-term sustainability of fish stocks and coral reef ecosystems. These measures help prevent overfishing, protect biodiversity, and maintain ecosystem resilience. Scientific research allows people to be aware of the issue and its harms. There are still gaps in our knowledge of coral reef ecosystem and the effects of overfishing. Despite advancements in scientific research, a lack of data, especially in rural or understudied areas, can make it difficult to create all-encompassing management plans. Is science helping or hurting the problem, and are there better sciences that could be used? Science is helping the problem as it is providing clear insight on what the problem actually is, how to solve it, and what can be used to fix the harms in a natural way. It also allows the spread of awareness, which is always useful. Science being used to solve this problem is crucial for the reconstruction of many coral reefs. Moreover, advancements in technology such as remote sensing, underwater monitoring systems, and genetic analysis technique have enabled scientists to collect data more accurately and efficiently, enhancing our understanding of coral reef ecosystems and the impact of overfishing. Science helps the environmental state of the world as it allows the reconstruction of coral reefs, which not only provides a home and living situation for many sea animals, but also provides food and hunting for many other species, not only the aquatic but also on land. The destruction of coral reefs hurts everybody as it destroys many ecosystems, so using science to help maintain it is always beneficial. Overfishing can have significant social and economic impacts on coastal communities, particularly those reliant for fishing for food security and livelihoods. By employing science to address overfishing, there's an opportunity to promote social injustice and equity by ensuring that coastal communities have access to sustainable fisheries resources and benefit from ecosystem conservation efforts. Although it seems to help all fisheries, overfishing does help the small business close, and restrictions against it could lead to the bankruptcy of many stores. This makes solving overfishing a complicated ordeal, as it is beneficial for the world but not necessarily for the fisheries in the short term. In short, overfishing is a big problem for coral reefs. It messes up the balance of fish and other creatures living there. But science gives us hope. By using what we know, like making rules for fishing and protecting certain areas, we can help coral reefs recover. We can also make smart choices when buying seafood and supporting groups that work to save coral reefs. It won't be easy, but with science and everybody's help, we can make a difference and keep coral reefs healthy for the future. Thank you everybody for listening.